Hi friends, welcome back to Hobby Plus. Today our discussion matter is op-amp. I mean operational amplifier. This is your operational amplifier or op-amp. The number is LM741. Now, so many electronic gadget, we see that the op-amp used in this gadget. But sometime we cannot understand this op-amp is working properly or not. It is really tested okay, it is functioning properly or not. We are confused in this part. So we cannot detect what is the actual problem. We think that op-amp not working, but problem is another way or another place or another circuit. Today we are just understand how the op-amp test by us and how we do this. Look at this. That is invert input. This point. That is the plus voltage. This point is invert input. That is non-invert input. That is null. That is null. We cannot discuss anything about pin number 1 and pin number 5 in this video. But that is pin number 6 is output of this op-amp. That means in op-amp there is two input. One is invert, another is non-invert. Almost all op-amps, if it is one op-amp device, then more or less pin number 7 is power in, pin number 4 is power out, I mean ground, pin number 3 is invert and pin number 2 is non-invert. In this circuit, here is a 15 volt. I think you don't see that. Wait. Look at this. There is a plus 15 volt and here is a minus 15 volt. Now the question is, I have no minus rail, I have no minus power supply in my lab, so how can I test it? Look at this. This is your DC power supply. You get ground here, that means 0 volt. You get plus volt here, suppose it is 30 volt DC plus. If you have this type of power supply, then you can make this easily. Put your ground in here. Put your positive in here. And look at this. If you put your 30 volt here and put your ground here, that means respect to ground you can get 30 volt in this point. But when you put two resistance together in series, that means 10K and 10K, that is protect the ampere draining. So it is likely little more value. So I put here 10K. So there is a 20K in series. That means minimal current flow through this line. One thing you have to understand and remember, op-amp never give you ampere. Op-amp never get ampere from you. Always remember that. So that is not important. Which type of resistance use here? Only important for do not lose your power through this rail and do not use any high wattage resistance in here. In that circuit, that is your 10K, that is your 10K. I mean R1 is 10K, R2 is 10K. That means you get here 0 volt. respect to this point you get 15 volt plus 15 volt here and minus 15 volt here. So when you make this type of network here, that means your op amp get minus voltage and plus voltage also. So you can make this circuit easily. Now look at this. That is your R3, that is also 10K, that is your R4, that is also 10K. So we easily calculate this, output voltage is 0. Now why? Because op amp always try to balance their minus pin with the plus pin. Very clear and simple to remember. That is your plus pin. Do not remember invert, non-invert, whatever it is. Plus pin and minus pin. No problem at all. So 4 resistance are same value. That means voltage difference between 2 and 3 is equal to 0. So you cannot get any voltage from the output of this op amp. Now I change the value of this point, I mean pin 3. Now if I try to get minus voltage in here, that means I have to change the value. It is very clear. If I make it, suppose 22K, that means I get here a minus voltage. When I get minus voltage here, that means what is your output? Remember that there is no feedback at all. The feedback means from output to input. There is no feedback resistance, there is no feedback network, there is no anything like as a feedback. When you change this value, your output goes to high or low. It cannot give you 0 volt. Never. But remember that always you measure your op amp every voltage from the 0 level. That means R1, R2 network, between the R1 and R2 network. From negative, that is your 0 volt, then you can measure everything. Then you can get minus 15 volt, then you can get plus 15 volt, everything. When you measure your output, so you also use this. If you use this is your ground, that means you get plus 15 volt here. So don't do this. When it is 0, then you get both resistance 3 and resistance 4 are same value, then you get 0 volt respect to this point. When you change this value or transfer this value to 22K, then you get here a minus voltage. When you put here a minus voltage means your pin 2 volt greater than pin 3 volt. Then output goes to low, minus rail. This output goes to minus rail, tends to minus rail. Why it is tends to minus rail? Because this output always try to equal pin 2 and pin 3. Always. And always try to compensate pin 2. So when pin 2 is high or higher than pin 3, that means your output pin make opposite, that is plus, that is minus. In that case, in this situation, that is plus voltage, that is plus voltage, and that is minus voltage, because it is negative voltage. So negative voltage greater than lesser than 0, so that is negative voltage. So you get here a negative rail almost. You cannot get minus 15 volt because there is so many resistance capacitor in this op amp, so it is goes to negative rail. Opposite also true. I mean, if you put this value as 10k and you make this value as 22k, then pin get positive voltage respect to pin number 2. That means what should happen? I told already, output pin always compensate to input pin. Input pin means minus pin. So when this voltage greater than, I mean pin number 3 voltage greater than pin number 2, the 6 always goes to higher rail, tends to plus 15 volt, because compensate. When I get plus 15 volt or tends to 15 volt, that means this op amp try to develop the voltage, generate the voltage for compensate this point pin as well as 3. Actually pin number 3 virtually connected with pin number 2. That is a logically connected. Logically, what is the logic? If it is 3 greater than 2, that means you get output positive voltage. If 2 greater than 3, you get negative voltage, because pin number 6, I mean output pin, always compensate pin number 2. It may be plus, it may be minus. When you get this, just make this circuit and test it. Just you can use breadboard. It is very easy and simple. You can test it, no problem at all. First of all, you test your op amp by this resistance network. Then you can sure yes it is working or not. But never think I get minus 15 volt but I cannot. I get plus 15 volt, I cannot. No. Tends to. That is not equal to plus 15 volt. Output never equals to my plus 15 volt or minus 15 volt, but tends to. Respect, I think you can get 12 volt, 13 volt, something like that. It may be positive, it may be negative. That means your op amp is absolutely fine and working properly. No problem at all. I think you can understand everything which I try to describe you. If you have any problem, if you have any doubt, or if you have more, what is the purpose of this 2 pin, or what is the feedback circuit, why it is necessary, why we use that, how type of coupling we can do, so many particle are there, so many topic are there. So I tell you everything one by one. I think you understand that. Please, you know what to do. Please do this. Thank you for watching.